All right, third time will be a charm here. I've gotten all these text messages show up about Mother's Day planning and everything else. But anyway, all right. So let's talk about this. Let's go through this one now. So we got a 2 kilogram mass that's allowed to bob up and down at a resonant frequency of 12 hertz. Okay, on the slide that talks about this, and we talked about it in class too, we've got the frequency is equal to 1 over 2 pi times the square root of k over m. Okay? Well, I need to find k. I've been given the frequency and I've been given m. This is algebra 1, all right, which is an expectation for this course. So we know how to do algebra 1. All right, so let's go ahead. So we get 2 pi times the frequency is equal to k over m. Now, how do you get rid of the square root? Right, you square both sides. Now, here's where I think the problem happened. Because when we square both sides, I wind up with 4 pi squared. A lot of people forget to square that too. Times f squared, which was given, is equal to k over m. Multiply both sides by m. And you get a pretty large number. You get a pretty big, it's a big number. All right, now, the next part, so that's problem 1. The next part is, it goes, well, what's the period? Well, the period is equal to 1 over the frequency. And they gave you the frequency as 12 hertz. Okay? All right. Okay, the rest of these, multiple choice. I'm not going to waste your time with those. Okay, now this is on an exam, right? But we know how to do this. We know this type of problem is on the exam. Okay? So on question 5, we've got this. For the period of a pendulum, it's 2 pi, because it's going to be the inverse of this, really, divided by L over M. The length, L over G. That's right, because we don't need a mass. The masses cancel. We found that out in class. In this case, t is equal to 1 second. All right? And you know that g is equal to 9.8 meters per second squared. I wouldn't plug in any numbers until I was ready to go. Okay? But once again, we got to square both sides just like we did up here. All right? Next one. Whoops. There we go. Now we've got a period of 0.87 seconds on problem 6. What's the gravitation? Now you take this pendulum, so you have to get the correct answer here in 6, which you can look up, you can Google what's the length of a 1 second pendulum, and it'll tell you. Simple pendulum of a certain length. Boom. I mean, it's there. Now you take this to planet X, you got to take this L that you got here and use it here in problem 6. Okay? And do the same thing again. You're just going to repeat the same problem again, but this time you're going to try and solve for G. You're just doing a little bit different algebra problem, so it would look like this. So in problem 6, take the answer from 5, which, like I said, you can look it up. Take the answer from number 5, and then go t is 0.87 is equal to 2 pi times the square root of answer from 5, the length from question 5, divided by this g on this new planet X. The g on planet X. So we got to tease the g out of there. No big deal. No big deal. Take 0.87 divided by 2 pi. Square both sides. Now this does get a little bit, I guess, gets a little bit tricky. But so g of x multiplied with both sides, and you get L5 divided by, I'd go ahead and get this number here. Figure out what that number is. Divide it here. because this you got from problem 5. Problem 5 divided by what you get here, and you're on your way. Okay? All right. What else we got? Okay, had some questions on this too. How much more? Jiminy Christmas. Oh, the rest are just multiple choice, except for right here, where we do a depends on where we swing the leg forward. All right, so okay, in the thing in the video, you got to watch the videos. It's 0.001 seconds. All right. So during this collision, a 90-mile-an-hour pitch, and the average force is 18,000 newtons. Okay, the maximum force is 36,000 newtons, but we're going to use the average force that takes place is 18,000 newtons. According to this data, what was the exit speed of the baseball? Now we did this, so on question 9. So on question number 9, we did first you got to convert 90 miles an hour to this is just the good old sorry, I've got about 10 things run through. This is just the good old impulse momentum problem, right? I is equal to the average force, which is 18,000 newtons in this case, times 0.001 delta t, which is equal to 0.145 times the final velocity minus negative 90 miles per hour. Where the final velocity is going to be positive. So you got everything you need except for this guy. So you can take the average force times delta t divided by 0.145, and that'll equal V final minus, well, we got to take 90 miles per hour, multiply it by 0.447, which the 0.447, remember, is equal to, there's 1,609 meters in 1 mile times 1 hour divided by 3,600 seconds. And that's where you get the 0.447. So the miles cancel and the hours, and the hours cancel, okay? Because it's per hour, so the hours are in the numerator and the denominator, so the hours cancel too. All right, that's where that came from. So VF plus 90 is equal to that. Okay? And you're going to get a pretty plus whatever this is. Sorry. All right. Now, 10. The actual is 110, well, all the above. Okay, now, here is question 11. Question 11. A wooden Major League bat has a mass of 880 grams. So the mass is equal to 0.880 grams, or kilograms. Okay? 0.880 kilograms. Now, the length from where the batter has his hand, so that'll be the end, we'll call that the end, is to the batter is about 0.762, so the length is equal to 0.762 meters. Now, using the equation of a thin rod for the moment of inertia, which is on that one slide, which is I is equal to 1/3 m times L squared. You got m, you got L. Shouldn't be hard. Okay? And so, there we go. None PF of the above. How about none of the above there, you? All right, so now we've got when we walk, our legs alternately swing forward, and this acts, find the time it takes for the leg to swing forward, treating the leg as a thin rod of 0.8 meters it acts like a physical pendulum, so we need the moment of inertia of a thin rod, which we've already done. That's one of the reasons I gave you this problem on 13. Okay? And I think we did this in class, didn't we? Pretty sure we did. Because the period of a thin pendulum, T, is equal to 2 pi times the square root of I divided by mgl. Okay? So you could go ahead and just calculate what I is. No, you don't want to do that because they didn't give you the mass. So we wind up with T is equal to 2 pi times the square root of ml squared. Now the 3 drops down here times 3gl times m. So the m's cancel. And we wind up with 2 pi times the square root, and one of the l's cancels, times L over 3g. So it's a little different than just a simple bobbing pendulum. In fact, it's a little bit smaller. Okay? All right. Any more on this? Nope, that's it. Okay, so that's it for that one.